In an emergency, the most dangerous moment is the delay between the first warning sign and the realization that help is needed. Despite an abundance of sensors in modern buildings, vulnerable individuals still suffer because current systems lack the ability to interpret silence. We are Team Sanjeevani AI from Symbiosis Institute of Technology. Our project, Sanjeevani AI, is a predictive intelligence layer built on the Myosa platform. Standard emergency systems are built on single threshold triggers. They wait for a manual button press or a solitary data point to cross a rigid numerical limit before activating. This reliance on isolated spikes creates two problems. Noisy sensors trigger frequent false alarms that lead to alert fatigue, while silent emergencies, those that develop slowly, often fail to cross the trigger line at all. Sanjeevani AI utilizes contextual sensor fusion. It observes how environmental, motion, and posture signals behave together over time to identify danger. True safety relies on understanding the relationship between multiple signals. A single number is just data. A sequence of numbers is context. To see how context functions, consider the mechanics of a common indoor fall. An isolated acceleration spike is poor evidence of an emergency. It could represent a dropped device or a sudden but safe movement. Sanjeevani AI requires a chain of evidence, an impact, followed by a sustained posture shift, followed by a lack of recovery movement. We apply the same logic to air quality. A single noisy reading is ignored, but a persistent worsening trend combined with the presence of a person indicates an escalating risk. Our system mathematically translates these overlapping time series patterns into a reliable risk metric. The system is anchored by the Myosa Mini IoT Kit. It monitors temperature, humidity, and air quality to define environmental stress levels. Simultaneously, the IMU and barometric pressure sensors track acceleration, posture, and human stillness. Interaction sensors allow the user to provide intentional SOS signals or to actively confirm their personal safety through specific recognized gestures. To ensure resilience, the system actively probes for missing sensors. If a module is disconnected, the system marks the failure, adjusts its confidence score, and continues monitoring. These components act as a localized sensory web, perceiving the room context much like a human caretaker would. The raw sensor data is processed locally by the ESP32 firmware. Edge processing allows the system to filter noise and extract features immediately, eliminating the latency of cloud-based analysis. We utilize a dedicated fall state machine to govern transitions. The logic moves from idle to a fall candidate upon impact, then to fall confirmed only if posture and motion data support the hypothesis. This state machine outputs a risk score from 0 to 100, which corresponds to 4 escalation states: safe, watch, warning, and emergency. To ensure trust, the system is explainable. It justifies its risk score using specific reason codes, such as multi-sensor risk or post-fall inactivity. Human operators can look at these codes and instantly understand the exact logic the machine used to reach its conclusion. The process data leaves the hardware as a machine-readable JSON stream over serial. The backend, built with Python and SQLite, stores historical readings and maintains a log of every emergency event lifecycle. We use Socket.io to broadcast sub-second updates, ensuring the live dashboard reflects the current state of the hardware without delay. External escalation is handled by a Telegram bot, which notifies relatives or first responders the moment an emergency is confirmed. This architecture allows the Myosa kit to operate as an integrated emergency workflow, linking localized sensing to immediate external response. The software interface is designed as an operator-focused command center. Here, the green SAFE badge confirms a stable baseline. The design philosophy emphasizes clinical clarity. It is intended to reduce cognitive load during a crisis by providing the most critical state information first. Under normal conditions, the unified risk gauge remains at 0, supported by a safe baseline report in the incident story panel. The complexity remains visible in the background. Our environmental graphs track high-frequency oscillations in temperature and air quality. Simultaneously, the motion physiology graph provides a live look at the user's posture through tilt and pressure waveforms. This dashboard bridges the gap between high-frequency raw telemetry and immediate human insight. Imagine a scenario where air quality worsens while the user remains immobile. The system detects the abnormal pattern and shifts into a watch state. It monitors the trend closely but avoids a premature alarm. As the environmental risk persists, the unified risk gauge climbs, and the recommended action updates to monitor quietly, alerting an operator to potential trouble. When sensors conclusively agree on a threat, the system state escalates to warning or emergency. Local buzzers activate, the hardware OLED updates, and a telegram notification is dispatched. Once the user recovers, they can perform a safe gesture to de-escalate the alarm. The dashboard logs the incident history, and the system returns to a clear state. Sanjeevani AI manages the entire life cycle of an incident, from the first subtle warning to the final resolution. Current personal safety tools have significant gaps. Smartwatches are limited to wearables, and traditional medical alerts rely on manual button presses. Similarly, environmental monitors provide data on air quality, but lack the physical context required to detect a person in distress. Future development will include multi-room networks, caregiver companion apps, and machine learning models trained on field data. For this IEEE submission, we have integrated the Myosa IoT kit into an environment that recognizes context and communicates risk. By detecting early, explaining clearly, and escalating intelligently, Sanjeevani AI provides a new standard for indoor safety and emergency response.